Hello and welcome to the Waters and Stanton video channel. My name is Peter Waters, G30JV. In this video, it's actually a constructional video really. You will probably be aware that I've done a lot of work in the past on end-fed half-wave antennas. In quick summary, the advantage of an end-fed half-wave is that if you feed it correctly and you have the right matching transformer, that half-wave antenna will work on harmonics. So, for example, a 40-meter antenna will work on 20 meters or 15 meters and 10 meters, which is very convenient. No traps, just the correct matching transformer. And it's also an attractive proposition for small gardens because, as you probably know, I've done a series on small gardens and the antenna problems there. It makes it fairly easy to fit a wire into a small garden. Let's take 40 meters for example. 40 meters is a wire that's approximately 20 meters long. By the way, if you want to calculate the length of half-wave, then there's two numbers you need to remember. 468. 468. Divide 468 by frequency in megahertz and you will come out with the answer of a half-wave antenna in feet. So the magic number is 468 if you want to work in feet. If you want to work in meters, then the magic number is 143. Divide 143 by the frequency in megahertz and you'll get a half-wave antenna length in meters. It's always sensible to actually add a little bit on to the answer so that your antenna is slightly longer than probably it will need to be. It gives you the chance then to trim it back in length to get it onto frequency. So those two numbers, 468, 143. Now that was my paddle key. There was a nudge with my arm. The wire can of course be bent around the garden somewhat. So you can have it as an inverted V, you could have it as an inverted L, or you could have the wire running down the garden and then a right angle bend and across the garden. And in a lot of gardens you probably can get the 20 meter length of wire in. Now there is a reason that I'm talking about this antenna again, which I'll cover in the next video. Some interesting projects that you might want to undertake that will give you a bit of fun, I think, with a small garden. Anyway, let's talk about the matching unit, because the matching unit really is key to this antenna. You need the right matching unit. I've done quite a bit of work on it and I've refined it because I've seen various videos on how to make these matching units, and I've refined it to a point where I think it's very, very easy for anybody with a soldering iron to quickly make a matching unit for the end-fed half-wave. So let's take a look and see what's involved. Right, this is the transformer that I've developed. This is an early version, but it will give you the basic idea. The ferrite toroid here is made by Ferrite. That's F-A-I-R-hyphen-R-I-T-E, American company. It's 2.5 inches diameter or 65 millimeters diameter. I notice now that core is available from RS Components in the UK. So if you go onto the RS Component site and type in Fair-Right, you should see this core coming up. This white tape here is plumber's tape. The only function of that really is to give a slightly better bed for the winding. Now, there's two unusual things that I've done here. First of all, I've used tin copper wire. The reason I've used tin copper wire is because It's easier to work with, easier to solder, and because the turn-ins are well spaced, there's no risk of it shorting across. So tin copper wire, I find, is far better than enamelled copper wire. Makes the assembly so much easier. The turns, right. This here is the earthy side. This basically is where the coax cable goes to. So we start with the winding here, we make 2 turns, and then we solder on a wire here. Now it's very easy to solder that wire on. If you put a screwdriver under the second turn and just lever it out very, very slightly, you can slip a wire underneath it and solder it. Again, that of course makes it much easier if you're using tin copper wire. So that turn, or that connection there, is on the second turn. Now I've avoided using twisted wires that you very often see in these transformers because I find, or I feel, that there's always a risk of the enamel copper wire shorting across on that very tight turn that some people use. So I've made a direct connection auto transformer style. I've used 5 turns, then go underneath and up, so that the next 5 turns are wound effectively in the opposite direction. That gives me basically 10 turns. Now, those turns are less than is often recommended. The reason I've only got the 5 on either side is that it tends to give better performance on the higher bands, on 15 and 10 meters. If you want to operate on 80 meters, in other words, instead of 5, you make 6 turns either side. The only other component you need to add is this capacitor here. This capacitor here is 100 puff, rated at 2 kilovolts. Again, you can get those capacitors in the radio spares catalogue. 2 kilovolts seems to be okay for 100 watts. The actual kilovolt rating is not critical if you can get a 3 or 4, well, so well and good. Basically, 100 puff and around about 2 kilovolts rating or more, and that seems to handle 100 watt power quite easily. So that's basically the transformer that I've been working on. As I say, tin copper wire is a bit unusual, but it's so much easier to work with, and that transformer will then enable you to attach an end-fed half-wave wire there, which has typically got an impedance around about 3,000 ohms, and just attach the half-wave wire there, and your coax here. That's the earth side of the coax, and that's the inner connector of the coax. And as I said before, I think that this matching transformer doesn't require an ATU at all. Most transceivers have got an antenna tuner built in, and if there is any tweaking, it can easily be done with the internal ATU, but you should get a low SWR. Half-wave connected to the one end of the matching transformer, and then coax back to your transceiver. The numbers I mentioned, 468, divide that by frequency and you get your half-wave length in feet, or 143, divide 143 by the frequency and you get your half-wave frequency in meters. Now, I did say this is leading on to something else, and indeed it is. It's leading on to something which I think if you've got a small garden you might find quite interesting. It's a possible way of getting some nice S9 reports with just 100 watts. We'll talk about that more in the next video. Don't forget, if you're interested in buying equipment, we've got the largest ham radio warehouse in Portsmouth. Got some great guys down there. They're all licensed amateurs, and they'll be happy to talk to you, whether it be antennas, accessories or transceivers. Be able to do some good prices for you. Part exchange, not a problem. So just bear that in mind. Yes, it's a nice, friendly company. Telephone number 01702 206 835. So, as usual, if you've enjoyed this video, please don't forget to press subscribe, because that'll alert you to the next video that's coming up. In the meantime, enjoy your ham radio. Thanks for watching. Take care.